Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Amalia binti Wan Mustafa Fazil. My metric number is 01DKA19F1113. So today we will explain about fluid characteristic in three methods. The content that we have is objective, apparatus, procedure, data, and calculation. Now I will explain for the first method, which is determination using density bottle method. The objective for the first method is to determine the density of a liquid and water indirectly using density bottle, and use 6 apparatus, which is density bottle, electronic balance, hydrostatic pressure apparatus, stir ruler, weights, and beaker. Hi, so continue with me, Wan Amalia, to explain about procedure density of fluid using density bottle method. The first step is clean density bottle with stopper using tissue. Then take the empty density bottle along with stopper, is weighed using balance, and note down this reading as M1. Repeat step 2 to record the mass of second density bottle. Next, include oils in density bottle base 25 ml and 50 ml full affected. For the another 2 density bottle, enter water to 25 ml and 50 ml to fulfill the space. The last step is weight of density bottle, oil, and record the reading. Repeat step 4 to weight of density bottle containing water and record the reading.
Hello everyone, my name is Atika binti Aziz. My metric number is 01DKA19F1108 and I'm from group C. So today I want to present about density bottle, which is data and calculation in method 1. So the data for density bottle, as you can see, we make 3 samples for this experiment, such as water, liquid B and liquid C. Then we also make 2 tests for every sample to make sure the data no error. So we calculate the data, for example, to get mass of water, liquid B and liquid C, we calculate the filled bottle in 134.75 must be minus with empty bottle is 34.64 and the equal is 100.11 in mass of water. And the analysis for 3 data sample, we calculate same as example and we'll get this as in the table. After that, for another data, we calculate an analysis for these 3 sample, we get this data. To calculate, we should follow the result of density bottle. We calculate before this and we just convert from gram to kg, like for empty bottle of water, we get 34.64 gram, and after convert to kg, we get 0.035 for empty bottle. Also for the filled bottle, mass of water, same as calculation for empty bottle, but for volume of bottle, we should convert from ml to m3. For example, the volume of water is 100 ml and convert, we get 0.1 m3, so same as for calculate liquid B and liquid C. Okay, we continue with the last slide. After we get the data from the 3 sample, we calculate that in another table. So after we calculate, we found that the liquid C denser than liquid B and water. To calculate of average density, we should plus 1 and 1 and then divide by 2 to get the average. So that's all from me about this experiment data and calculation by using method 1, which is density bottle. 1DKA19F1108 and I'm from group C. So today I want to present about the procedure of hydrometer reading and temperature in method 2. So using hydrometer and thermometer, For water, fill the measuring cylinder with water from the tap until maximum reading scale. Very carefully, place the hydrometer into the cylinder until the bulb reach very near the bottom of the cylinder. Do not drop the hydrometer into the measuring cylinder. Very gentle, release the hydrometer and let it settle in this free state. When the liquid surface become calm, read and record the hydrometer reading. Carefully take out the hydrometer, clean it and place it back into its casing. Using a thermometer, record the water temperature and empty the measuring cylinder, clean up and tidy up. For test liquid, first repeat step 1 to 5 with any other two test liquid. Record the container marking of the test liquid respectively. Pour the liquid back into the container and clean up and tidy up. So that's all for me to present about hydrometer reading and temperature in method 1.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Azizul Hakim bin Yusof. My matrix number is 01DKA19F1101. So now, I would like to present the experimental data about hydrometer and temperature reading. First of all, you can see the data looks so simple because this is the data from direct method. Okay, so let's take a look for the column. It's shown the water, liquid B and liquid C. For the row, it's shown a hydrometer reading and temperature in Celsius. The data that you have is you take from the experiment that you done.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Nur Muhammad Haziq bin Ahmad Fuad. Nombor matrik saya 01 DKA19F 1097. Okey, untuk slide ini saya akan menerangkan mengenai calculation direct method. Okey, untuk calculation direct method ni kita akan buat 3 jadual, iaitu jadual pertama kita buat water, kedua liquid B dan ketiga liquid C. Liquid B dan C ni selain daripada water, macam minyak dan macam selain water lah, minyak dan sebagainya. Okay, untuk hydrometer reading, water kita dapat 1, liquid 0.85, liquid C 0.98 dan density of water in kilogram meter cube. Water kita dapat 1000, liquid B 850, liquid C 980, di mana satu tu kita kalikan 1000 macam water, liquid B 0.85 kita kali 1000, kita dapat jumlah tersebut. Dan temperature reading kita boleh tengok lah, water 27, liquid B 30, liquid C 28. Okay, untuk fill in the table below, dalam jadual ni kita tengok direct pada mesin tersebut, di mana ada specific weight, dynamic viscosity, surface tension, vapor pressure, elastic modulus. Okay, semua maklumat yang perlu diisi dalam table ni ada pada mesin tersebut. Okay, sebab itu dipanggil direct method, iaitu kita ambil maklumat secara direct pada mesin tersebut. Okay, itu saya dari saya. Assalamualaikum, bersama saya Nur Muhammad Haziq bin Ahmad Fuad. Nombor matrik saya 01 DKA19F 1097. Okay, untuk slide kali ini saya akan menerangkan procedure of hydrostatic pressure. Okay, number 1, position the balance arm on the knife edge. Place the weight hanger on the end of the balance arm and level the arm using the counterbalance. Next, add 50 gram to the weight hanger and add the water until the quadrant is balanced. Number 3, record the water height which is displayed on the side of the quadrant in millimeter. Next, repeat the step adding 50 gram weight each time until the final weight of 500 gram is reached. And the last, reverse the step by removing 50 gram weight each time. All the reading should be tabulate. Okay, that's all daripada saya. Okay, terima
Now I
kasih.
will explain the data for method 3 hydrostatic pressure for indirect method. As you can see, there have two tables. For the mass on hanger, the first table is in unit GM and the second table is in unit kg. So let's look at for test 1, which is in table 1 50 and for table 2 0.05. So to get 0.05 is 50 divided by 1000. Same for test 2, 3, 4, 5. Just divide by 1000. Next, let's see for water depth. For the table 1 is in millimeter and for the second table is in meter. So how to get adding up, reducing down and average? Let's see for test 1. Table 1 is 46.5. Divide by 1000 and you will get 0.047. For reducing down, for test 1, 47 divide by 1000 and you will get 0.047. And for average, test 1, 45.5 table 1 divide by 1000 and you will get 0.046. Just divide by 1000 for test 2, 3, 4 and 5. Next.
Okay, now let's continue about the calculation of hydrostatic pressure. Based on the table, on the first column we have test 1 until test 5. The next beside it we have mass on hanger in kg. The next beside it we have average water depth in meter. We can obtain this from the experimental data that we have done. For the y power 2, we just calculate average water depth power 2 and put it in the column number 4 on this table. For m per y power 2, we just take the mass on hanger divided by average water depth power 2 and we get the right data calculation.
Next, for graph hydrostatic pressure, y stand for m over y square and x stand for average water depth. The graph is based on calculation that we get. So look at y-axis. On the top you will see 24.7. How to get 24.7 is make one line that will touch 2 points of graph. The first point that we get is for the top 23.63 and the last 22.25. So the m that we get is negative 23. How we get is y1 minus y2 and we get 1.38 and x1 minus x2 we get negative 0.06 and last 1.38 over negative 0.06 we get negative 23. That's all from me. Thank you.